Okay, once again, let's start with our equilibrium. HA plus water goes to A minus, that's our conjugate base, plus H3O plus. Now, we've said over and over again to look at this equilibrium and decide how reactive is our base. We're going to look at the stability of our conjugate base. And we'll focus on the conjugate base because it has a negative charge and we need to be able to evaluate whether that charge is stable or unstable. We have never mentioned how do you decide whether a negative charge is stable or unstable. Well, as it turns out, there are 6 factors for charge stability. And this isn't an official list. This is simply my list. This is the way I view this. Other people present it differently. This is the way I look at it. So six factors for charge stability. Fantastic. Number 1, we're going to need to look at the electronegativity, and lowercase e capital N is a shorthand notation for electronegativity. The electronegativity of the atom that bears the charge. So electronegativity is going to be important. Is that atom more or less electronegative? We'll see examples of this, but more electronegative atoms don't mind having a negative charge on them. Less electronegative atoms would prefer not to have a negative charge. That is a factor of stability. Factor number 2. Not the electronegativity. Let's just go back and see if we can erase that. That's a little nicer. The size of the atom that bears the negative or the charge. So the size of the atom is important. The electronegativity of the atom is important. And these are both periodic table trends. Two very important factors. I will say very often the atom that's bearing the charge and every time we're going to make a comparison, they're both going to be carbons. So the electronegativity is going to be the same and the size is going to be the same. It's not always going to be the case in everything, but for many of our examples later in the semester, everything's about carbon. So electronegativity and size specifically aren't that important. There is something called the inductive effect. And we'll see examples of that. That affects charge. There's something called resonance, which helps spread charge out. That's important. We'll have to be introduced to that properly later. The hybridization of the atom certainly can affect whether the charge is stable or not. And then there's another thing called hyperconjugation. This is kind of an orbital effect. And that can have an impact. As it turns out, these 6 factors that we can use to evaluate charge stability don't just apply to anions or cations that we might see in acid-base reactions. They apply to anything that has a charge. And a lot of reactions form charges during the reaction. So by learning these tools and practicing applying them to acid-base chemistry, we're practicing applying these tools later to other general organic reactions that involve charge. So this is why acid-base chemistry is such a great way to kind of dip our toes in the water of the larger pool of organic chemistry. It's going to make us much better able to pick up advanced organic reactions later on. So in later videos, we're going to look at these 6 factors and see specific examples and know how to recognize and apply these ideas.